volcanoes we know well. They call attention to themselves with towering ash plumes, fiery flows of lava, and the small earthquakes that often precede eruptions. Then there are volcanoes like Mount Getty, an active volcano that looms over the western tip of the Indonesian island of Java. Millions of people live on its flanks and in nearby cities. The volcano's last outburst was in 1957, long before modern monitoring equipment was put in place. So scientists know little about Getty's temperament. How much warning will people get before it erupts? A new technique called diffusion chronometry is providing answers. It depends on the idea that tiny crystals harvested from erupted ash and rock contain stopwatches. The crystals first grow out of magma in chambers deep underground. If something happens to the environment where they are growing, these crystals can grow rims that are chemically different, like rings inside a tree. For instance, when a new pulse of magma comes into the chamber, potentially triggering an eruption, it often has slightly different chemistry, which is recorded in the growth ring. The crystals continue to sit in the chamber for months, years, or longer until the volcano finally erupts. During that waiting time, the boundary between the crystal core and rim gets blurred. Atoms diffuse across that boundary, making each side less chemically distinct. Using a microprobe, scientists can measure the shape of that more gradual chemical transition across the crystal face. The shape, in turn, can be used to calculate the length of time the crystals sat in the magma chamber before eruption. At Mount Getty, researchers found rocks and ash from 5 different eruptions that occurred thousands of years ago. By examining the chemical diffusion in crystals from those rocks, they found that in each eruption, about a month elapsed between the last pulse of magma and the eruption itself. Useful information for hazard planners. Of the more than 1,500 potentially active volcanoes on Earth, only a small fraction are actively monitored, and fewer still have erupted since scientists started watching. With diffusion chronometry, researchers can collect crystal in rocks from different eruptions and use them to learn about the personalities of these silent volcanoes, thus helping them understand a volcano's future by using its crystal clocks to look deep into its past.
Thank you.